Well, we'll see how long
Do
it
we
goes.
put those grades in Blackboard, or do we need to still come ask you for an overall grade?
I'm trying to think what, I think Blackboard is up to date at the moment.
Okay.
Oh, it is.
Not sure, the individual grades are up to date. The overall grade is, until there's a test, it's not quite sure really makes much difference. All right, so I think I'm recording. Any questions? Other than Shakaya, whose questions apparently are too good for you. I heard an when my wife says she needs me to stop whatever I'm doing so she can tell me something. Okay. All right, so the two things I would like to accomplish today. One of which, well, actually three things to include, see your smiling faces, which that's partially successful here. Some of you aren't willing to smile. Even though it's physics, so I'm not quite sure what the deal is there. I'm gonna work through, this is a lab that we did not do. So I'm just gonna work through sort of a crude estimate of it. There we go. So, we have a projectile launcher. And don't worry, there will be a later lab where you're using a projectile launcher. First rule is safety rules, don't shoot your eye out, okay? That would be bad. There are 3 settings to it. You can judge by the clicks. That did not go. 1. Apparently, I can't count clicks. Oh, part of it is this is loose right here, which is releasing it from some of it. One. I picked the wrong one. 2, 3. All right, so that's the alarm setting right there. And I want to close the door enough so that I'm not chasing it down the hall. Give you an idea on the long setting. We'll shoot it that way. All right, so that's the long setting right there. And what I want to do is figure out how fast is it coming out of the barrel, and then use that to make a prediction about how far we can actually shoot it. Now, to figure out how fast it's coming out of the barrel, we could put a motion sensor right there, figure out what the width of the ball is, and so we can figure out how fast it's going, but a little bit more sophisticated method of doing it, okay, or perhaps a less sophisticated method of doing it, is we're going to shoot it horizontally. Because it is off balance like this, the center of mass is just barely over this right here, we do need to use the table clamp. I want to be able to shoot it completely horizontally. So why would that? What's the advantage of shooting it horizontally if I want to figure out the speed?
You can watch it easier if it's going horizontally, so you know when to stop the timer.
So that is a possibility. Probably you'd have, if you shot at an angle, if you were using your reflexes, that might work a little bit better. But if I shoot this ball horizontally, what can I calculate? Badly worded. How long is the ball in the air? Without timing it. Not that long,
1 second.
not even that long. It's under a half second. How can we figure out how long the ball was in the air without pulling out a stopwatch and trusting reflexes?
See what force it's shooting it at and how far it's going.
Calculate the force with the shooting, is that what you said? We could potentially do that, and not, that's a chapter 4 or 5. There was a master set question that dealt with shooting a ball off the table at, I think, 25 meters per second. How fast does the other ball need to go?
Also 25 meters per second.
You said 25 meters per second?
The other ball?
It does not have to be. Now, I know at least one of you in here got this right. Let's just do a quick little test here. I don't have a ruler, so we'll use the top of the floor. Take 2 masses. Just for control, 2 of the same mass. Those are roughly the same mass. I'm going to project these off of the table at the exact same time. I'm going to do it by sort of slinging this, so this is going to be moving faster than this will. I'm going to put it back some. So as I sling it, the farther it is away from the fulcrum, the faster it's going to be going, considering that they'll have the same angular speed. And some of this is vocabulary from a few chapters. Which one will hit the ground first?
Probably the one that's not going as fast.
All right, so you're going for the slower one will hit first, okay? Anyone else? Or is Miranda the spokesperson for
Probably the
today?
slow one too.
Another vote for slow,
They should be at the same time, right?
and a vote for neither, or both, whichever way you want to go. Anyone for faster? Got one for faster. Is it just, are you going to commit to one, or just, it's not, Ethan's wrong?
Neither.
Neither? Any commitment from this row?
The slow one?
All right. Gaia, do you want to just stand up and go, Jen, what were you thinking?
I was gonna say neither.
Neither? All right, so let's find out. Get this right. Which one hit first?
I couldn't see.
Did anyone see?
No.
The one that was closest to you?
I was thinking, listen to the,
It looked like about the same time.
yeah, there we go. And while I'm here.
Tweak your back, Dr. Fox.
No, it was my knee. It's like I kneeled on something I shouldn't have. And it might have been my knee that. Okay, listen to the sound.
I think it was the one closest to you that time, from what I can see.
They're same time.
When you first heard the thump, did they hear the thump about the same time?
Yes.
You didn't catch, Kristen, you disagree?
Oh, I couldn't see it.
That's listening for the thumps.
Sorry, I'm partially deaf. We had this discussion yesterday.
We'll do it one more time for those skeptics. Listen for the thumps.
They're about the same.
Yeah, it's about the same. That's hopefully what I would demonstrate there. So, how fast does another one need to go if it's being shot horizontally? Any speed would work. So, I can figure out how much time it's in the air just by figuring out, well, if I just drop this object, how long does it take to fall? So I just need to know the distance, the height there. And I just happen to have a meter stick. And that's a little bit more than a meter. So I just happen to have measuring tape. Now, on the side of this thing, should have brought a second one, but I didn't. On the side of it, there is a big white circle right there. That's where the ball is when it stops being forced. The spring ends just before that. So basically when I'm measuring the height, it's from the bottom of the circle to the ground is the height that I want. I'll move this one around. Don't worry, I'll move more furniture in a moment. All right, so I need to figure out the height of the ball when it is launched, or how far it is going to fall. I'm doing some very sophisticated measuring right here. Looks like 101.4 centimeters. Or 1.014 meters. That's how far it is going to fall. What is the acceleration due to gravity?
Negative
Again.
9.8 meters per second squared.
Say it again.
Negative 9.8 meters per second squared.
I would nitpick two things there. Someone else nitpick for me.
You have to define what direction is negative and positive.
Okay. And
You have to say we're on Earth.
are we on Earth?
Well, that's beyond.
You want the gravity to be in North Carolina.
More specifically, Winston-Salem. What is the acceleration due to gravity here?
9.798.
Acceleration due to gravity is a positive number, unless you're somehow dealing with an anti-gravity field or something like that. Whether it's positive or negative depends upon how you define it. So, you're gonna make down positive or negative.
Negative.
Apparently Ethan wants a negative. Cooper, you're backing him up?
Yeah.
So, we put down our, basically, the 5 things. Since up is positive, as established by Ethan and Cooper, my displacement, what's my displacement gonna be?
Negative 1.04 meters.
Negative 1.014 meters, all right? What else do we know?
The initial velocity,
Is,
is it 25 meters per second?
no, we're trying to figure out how much time it takes this ball is gonna be in the air, so we're looking at an object just falling.
It can be 0 meters per second
Yeah.
squared.
Vertically, it's 0. We'll get at vertical stuff. What else? We know one other thing.
Acceleration.
Which is,
Negative 9.798.
all right. Is the acceleration constant while it's falling? So we got cake and formulas. Which cake formula do we need to use? Or should we write them down? Without looking, what are the cake formulas? I think as a group, surely we can get all 4.
VF equals VI plus AT.
These are vectors. Okay, there's one.
Displacement equals V VI plus VF over 2 times time.
Okay, there's two of them.
VF squared equals VI squared plus 2AT
Close.
S.
Delta S. S, X, whatever letter you're using. And the last one,
X of T,
sorry, which one?
X, parentheses T.
Oh, okay.
Or V of T. I'm cheating, I'm looking.
You're writing it as in functional notation. Okay, sorry. So you did X plus T.
Is X 0 plus V 0 times T plus 1/2 acceleration times T squared.
Whereas I tend to write this one, delta S is equal to VIT plus 1/2 AT squared. Those are the same equation. All right, so we need the equation, since we're solving for time, we need the equation with time in it, but we don't have final velocity, so we want basically the equation that doesn't have final velocity in it.
The last one.
Yep. So negative 1.014 equals VI 0 times T plus 1/2 negative 9.798 T squared. Conveniently, that drops away. So what is T equal? It's going to be time enough. Wait for something. Wait, 4.6?
Yeah.
Let's do 3 decimal places.
455.
All right. Assume anyone else get the same thing? Or we're just trusting Daniel? We got it, okay, we got it back. All right. All right, so now I know how long this thing is going to be in the air. I'm going to shoot this. All of this is the same. This is all vertical stuff. Horizontal, I am going to just say that it's going to be shot in the positive direction horizontally. We can go ahead and establish that as I hat, J hat. So the vertical, this is all J hat stuff, and the horizontal, this is I hat stuff. We need to figure out how far it's going to be shot out. We're trying to find this. I know my time is going to be 0.455 seconds. What's my acceleration going to be horizontally?
0.
Any units for that?
Meter per second squared.
So which equation, we're going to do it experimentally, we're going to shoot it, see how far out it goes. Which equation will we be using?
We need to find the final velocity to define final vertical velocity to define the final horizontal velocity.
In order to find this, we need to know that, so, but we don't have to find this. Other than the fact that I know they're equal.
Oh wait, is the initial velocity still 0?
Say it again?
Is the initial velocity still 0?
Not vertically it is, but horizontally, no. How fast this thing, if I'm gonna shoot this thing horizontally, how fast it's coming out of the barrel is gonna be all horizontal.
Didn't you say it was 25 meters per second?
That was just the master set problem.
Okay.
We don't know what it is yet. Pretty sure it's not 25 meters per second. That would be on the dangerous side, I think. Because that'd be 50-something miles per hour. Yes. Let's take lab equipment that shoots things over 50 miles per hour. First, let's make sure it's on 0. This one happens to have a plumb bob on it. Not all of them do, in which case you need to get an angle indicator and put it on there. But that's pretty darn close to 0, so that should be horizontal. Now, if this were officially a lab, I'd figure out roughly where it lands. I'd put a piece of aluminum foil and get exactly where it hits. But hopefully it won't go more than 5 meters. So I'm gonna need someone with eagle eyes to figure out where this thing hits. All right. Use the ramrod. Now, one of the issues in an actual lab is that as I push back on this, if I just push like that, the table might scooch some, and so what I generally recommend is you put tape on the ground somewhere, something, so that if the table moves, you can easily put it back. I'm just gonna brace it with my body like this. Put it on the maximum. Another thing with the projectile launchers is it does matter how you pull on it. If you pull it softly, it won't go as far as if you pull it hard. So whatever you do, be consistent. All right, I think you four will have the best view about where it hits, and hopefully you will agree. All right, here we go.
Looks like it was right by.
So, here.